The first step here is that we don't have an integral rule. We cannot simplify it because we have two terms in the denominator separated by that plus sign. And so that means that the only way through this is our u substitution. Now, we talked about if there's ever a toss-up as far as what to pick, you want to pick u to be the denominator. So I'm going to try, and we'll see what happens with this, but I'm going to pick u as sine of 3x plus cosine of 3x. That will give us that our du, the derivative of this, we will need to use the chain rule on the sine of 3x and also the cosine because we have that outer function and inner function. So using the chain rule here, the sine is going to become cosine, keep the inside fixed, and then multiply by the derivative of the inside. So that is just 3. All right, then we have our cosine. Cosine is negative sine when we differentiate. Keep the inside fixed, and then multiply by the derivative of the inside, which is just 3. All right, so this is our u and our du key for converting this integral. Now, we don't want to make this too sloppy, but I do want to make one note. This du, of course, needs a dx here. So all of that is going to be multiplied by dx. All right, so we start off and we notice that just from the definition of u, this whole denominator can be replaced by u. So this whole denominator is getting replaced by u. Then from the definition of du, we got to somehow get all of this in the numerator to look like this. So the starting point, so again, we want this somehow to look like our du. So we might start by factoring out a 3, and that will give us cosine of 3x plus sine of 3x dx. Now, that's pretty close because we have a cosine of 3x, we have a sine of 3x. Now, and then that's not a plus, that's a minus sign, sorry. So minus sign because that minus will come straight down. Now, the problem though is that we're off by a sign. So here we have a positive and here we have a negative, same thing, here we have a negative, here we have a positive. So because we are off by a sign, what we're going to do is we're going to make the executive decision to factor out a -1. And that will switch the signs for us. So we factor out a -1, and that will give us -3. Now, when you factor out the -1, that's going to change the signs inside of this factor. So this will become negative cosine of 3x plus now, changing the sign, sine of 3x dx. All right, so at that point, again, we're trying to get this du to look like this numerator so that we can substitute it in. So we could switch this order, that's perfectly acceptable, get sine of 3x minus cosine of 3x dx. And that is our alternative definition of du. Okay, so let's look at the integral as it currently stands and see where we can go from this. So we have the integral of sine of 3x minus cosine of 3x dx over, and we said the denominator, all that denominator can be replaced by u. Now, if you look at trying to get this du to appear here, you have the sine of 3x, you have the negative cosine of 3x, and the dx, but you do need a -3 here. So you would have to multiply all of this in by -3, and then divide by -3 to balance it out. So once you do that, then you can say officially and finally that all of that numerator is going to be, by definition, du over u, and then the -1/3 will take a 1. Now, at this point, we have an integral completely in terms of u. So now we are ready to integrate. And when we integrate, again, you could bring this up, but when you bring it up, you get a 0 in the denominator. So that tells you that it's the natural log that you're looking for. And again, you want to be able to recognize this as 1 over u du. So this becomes natural log absolute value of u plus c, and then of course the constant tags along. Now, once you integrate, then you are going to substitute back. So the definition of u, by definition, it was kind of a long one, was the sine of 3x plus cosine of 3x. So I'm going to substitute that back in, sine of 3x plus cosine of 3x, and then plus c. And that will be our final answer in terms of this particular definite interval.